This week we will be looking at exponential and logarithmic functions. And so in order to work with exponential and logarithmic functions, we have to be familiar with some exponent rules. And so here we can see if you have two exponents, x to the m power and x to the n power, if they have the same base, that the base is x here, then we can just add the exponents. So we would get m plus n. The quotient rule says that if we have x to the m divided by x to the n, notice that the x, that's the base, is the same. Then we're just going to subtract the exponents. And then the par rule says that if we have x raised to the m power raised to the n power, then we're going to just multiply the exponents. And then the power of a product rule, x times y raised to the n power, is going to be equal to x to the n times y to the n. And the power of a quotient is going to be x divided by n to the power of n will be x to the n power divided by y to the n power. And then the zero exponent rule is anything to the zero power is always going to be equal to 1. And the negative exponent x to the negative n is the same as 1 divided by x to the n. So the exponential function f with base b is defined by f of x equals b to the x or y equals b to the x, where b is a positive constant other than 1 and b is greater than 0 and not equal to 1. X is any real number. So the main difference here is that our base is a number and the exponent is a variable. So example 1, determine which of the following functions are exponential functions. So here we get f of x is equal to x squared. So notice that our base is actually a variable. And this equation is actually quadratic. So this is not exponential. Here our base is 3. So our base is greater than 0. It's not equal to 1. Our exponent is our variable. So this is going to be exponential. And then here our base is a 2. And then we have x plus 1. So it has a variable in it. So this is going to be exponential. And then we have f of x equals negative 1 raised to the x. So our base here is negative 1. And so notice that it fails this part of the requirement, be greater than 0. So this is not exponential. Given f of x equals 16 to the x power, evaluate the following. So we want to know what f of 1 is equal to. So we're just going to replace the x by 1. So we get 16. So f of 1 is equal to 16. For f of a half, we do the same thing. So anywhere I see an x, I'm going to replace it with a half. So if you use a calculator here, make sure to add parentheses around your exponent. Whenever you have an exponent as a fraction, that actually means the square root of 16. So the half is the same as the square root. If you had a third, let's say you had 16 to the 1/3, then this would be the cube root of 16. So the denominator is going to be your index. If you had 16 to the 1/4, then this would be 16, the fourth root of 16. Our index is 2, but you don't have to write it. It's a square root. Okay, f of 3/2. So here we have f of 3/2. So that's 16 to the 3/2. So again, you can use your calculator. Just make sure you put parentheses around the 3/2. But this just means there's a fraction. So the 2 is a denominator. So that tells me I have a square root. So I have the square root of 16. And then the numerator, it means that we're going to raise that to the third power. So actually, let me come back over here and finish this problem. So the square root of 16, 4. F of 3/2. Square root of 16 is 4. Cubed would be 64. So f of negative 1 is equal to 16 to the negative 1. Since we have a power of negative 1, then we can use the rule number 7. So we get f of negative 1 is equal to 1 divided by 16. If we had 16 to the negative 2, then that would be 1 over 16 squared. We replace x with 0. Anything to the 0 power is going to be 1. And that was rule number 6. Okay, so the different forms that you'll see here for the logarithmic form, we have y is equal to log b of x. And the b here, this is going to be your base. And then we have something called the common logarithm, and that has base 10. So log 10 of x. However, since it's a base 10, we don't write the 10, so you'll see it written as log x. So if it's missing the little base here, then you can assume that it's base 10. And then for the natural log with base e, we have log e of x, but instead of writing log e of x, the log e is replaced with ln, natural log. These two can be found in your calculator. So for example, let me show you the calculator here. So here's my log key. And then the natural log, we would do second natural log. Or if you have a graphing calculator, so in the graphing calculator, you'll see the log right here. And then the natural log is this ln key. So if we wanted to find the log of 4, we would enter it. And that would have base 10. If you want to find the natural log, then we would press natural log of 4. And that has base e. The exponential form is written as b to the y equals x. Again, b is your base. And notice that y is an exponent. And so your log here is always equal to that exponent. So log 10,000 equals 4 is written in exponent in log form. In exponential form would be 10 to the 4th power is equal to 10,000. Log 10 equal to 1 would be written as 10 to the 1 equal to 10. Natural log of e is equal to 1. That would be written as e to the 1 is equal to e. And natural log of 1 equals 0. That would be e to the 0 equals to 1. So basically, if you have log of 10,000 equal to 4, notice that the base is missing, so there's a little 10 here. And so if we want to write it in exponential form, then we write the base, which is 10. And then I always like to ask myself, the log is always equal to the exponent. So since this log is equal to 4, then that's going to make 4 your exponent. And then the other number will go on this side. Okay? So if you have log of 10 equal to 1, then there's a imaginary base number here. So your base is 10. The log is equal to 1, so that's going to be your exponent. So this would be your exponential form. Natural log of e is equal to 1. So here, whenever you see ln, that is the same as saying log e of e is equal to 1. So natural log is log with base e. So my base is e. So I write my base. And then this whole log is equal to 1. So I write 1 here. And then my other number was e. Okay, so let's practice converting back and forth. So it says write each exponential function in logarithmic form. So your base here is 2. So since we're trying to write it as a log, I'm going to write the word log. my base is this little number here, and I'm going to have a number in here and then something equal to it. So the log is always equal to the exponent. So your exponent is 3, so that's going to be on this side, and then your other number will go in the parentheses. Here your base is 2, so I'm going to write log. My base is a 2. The log is equal to the exponent. In this case, the exponent is -4, and your other number is 1/16. Another way you can check your work is, notice that you have a 2 here and the 3. So is 2 cubed equal to 8? And that's the number that you get in here. Okay, so let's go to the next one. Cube root of 8 is equal to 2. So here, first, let's rewrite the cube root. Remember earlier I mentioned that if you have a cube root or any root, that's the same as a fraction. So since it's a cube root, that's going to be a 1/3. So my base is 8, so I'm going to have log of base 8. The log is equal to the exponent, in this case a third. So we get 2. My base here is b, and the log is equal to the exponent, in this case 3 is the exponent of 1000. Okay, the next one, write each log into an exponential form. So your base here is a 2, so I'm going to write my 2. And then the log is equal to the exponent, so that means that 6 is your exponent. So I'm going to write it up here. And then your other number would be on the right side. So here my base is 6. The log is equal to the exponent, in this case -2 of 136. My base is 49. The log is equal to the exponent, in this case a half, is equal to 7. My base is b. The log is equal to the exponent, in this case 3 of 27. Natural log of 7, if it helps, you can rewrite it as log e of 7 equals 1.9459. So the base is e. The log is equal to the exponent, so 1.9459 is your exponent. We get 7. Okay, so earlier I mentioned that the calculator has this log button here. However, that is only for base 10. So if you had something like this problem, since it has a base 5, we cannot use this calculator. There are some calculators that have the key that looks like this. So you would just enter your numbers 5 and 13 and press equal, and it would give you your answer. However, if you're using a TI-84 or some of the TI calculators, they don't have that symbol. Okay, so it's okay. We'll use something called the change of base to help us solve for those answers. And so basically what this is saying is, if you have a log that looks like this, we can rewrite this as log x divided by log a, and then we use a base that we'll be able to use in our calculator, which would be a 10 or e. But notice that the x goes in the numerator, the a goes in the denominator. And so we'll use base 10. It would look like log of x divided by log of a. Base e, this should be e, would be log a of x would be equal to natural log of x divided by natural log of a. Okay, so what this means is, if you have a problem like this one, then we can rewrite it, since we can use our calculator in this form. We're going to rewrite it as log 2506 divided by log 7. The base is going to be a 10, but you don't have to write the 10 in there. You can just write the word log. So then what we would do is we would put this in our calculator. So I'm going to have log 2,506, I'll put parentheses, divided by log of 7. Enter. So my answer is approximately 4.02. And you can round if it asks you to round. Okay. Or you could also use the natural log if you prefer. So depending on your calculator, if you have a TI-89, then changing this to the natural log would be easier than using the word log. So if you use natural log, then we would have natural log of 2,506 divided by natural log of 7. And notice we get the same answer. Okay, so log 5 of 13 is going to be log 13 divided by log 5, or natural log of 13 divided by natural log of 5. So the answer, log 13 divided by log 5 is 1.594 log pi 63. We can write as log 63 divided by log of pi, or natural log of 63 divided by natural log of pi. So we have log of 63 divided by log of pi. So 3.619. Okay, so in section 3.1 and 3.2, you'll be asked to convert from one form to the other and to evaluate simple equations. One of the methods would be to use the one-to-one property. And you'll have something like 4 to the x is equal to 4 to the 8th. And so if you have a situation like this, if the base is the same, then you can just set your exponents equal to each other, and that would be your answer. X is equal to 8. Okay, so sometimes you'll have it as 4 to the x is equal to 64. Okay, so here the bases are not the same. However, the 64 can be written as 4 cubed. And now that they are the same, then you can set the exponents equal to each other. Okay, so if I had 5 to the x is equal to 125, then we can have 5 to the x. 125 is the same as 5 cubed, so x would be equal to 3. Okay, and sometimes you'll have x plus 1 is equal to 36. So here you would have 6 to the power of x plus 1, and then 36 is 6 squared. So x plus 1 is equal to 2. So we would subtract the 1, so x is equal to 1.